Alright, welcome. In this video I'm going to try to show you what I know about vertical curve alignments. It's not much, but it could help you understand them and use them a little more easily. So in this case I've got points that are populated here along this vertical curve alignment, and they were populated using Excel, given I think we have the point 1, point of vertical curvature, point of vertical intersection, and point of vertical tangency. So you have basically have the coordinates of those three. I think what's given is the width, the length, and the elevations of these three. So let's go into the Excel, and that could change. I mean, there's 100 varieties of how you're going to get what kind of information you're going to have, but no, not 100. But in this case, I just got basically the location of these three. You may have the length and the slope of each, and then it would just vary a little bit when you got into Excel. All right, so there you go. There's your length, the elevation of point 1, elevation of the point of vertical tangency, and a point of vertical intersection. Let's see what I got here. I thought that's what I had. Here's 290. That's point of vertical tangency, yeah. And point of vertical intersection. 683. Yeah. Okay, yeah, so that looks right. So I've got the elevation, PVI. Enter. So elevation of point of vertical curve, point of vertical tangency, point of vertical, they're just not in order. So that's the given. So, and just so you know, like the way I did this is you select everything, right, by clicking that corner, and then hold Control, this one, this one, this one, and this one, and then right click in the gray, go to Format Cells, and then click on Lock, then say OK. And then these, I did it already, but I'm showing you how. You click on those four that you want to be using as your variables that you can insert. And you go to Format Cells, and then you leave it unlocked, right? Both unchecked. And you can go to Review, and then click Protect Sheet. You don't need a password. Really what this is going to do is going to help you from coming in here and changing a formula, right? So as you get in there and you start working and you accidentally change it, it could throw everything off. And that's how you protect that cell. So I'm going to unprotect it, actually, and then I want to show you something else. So I could do, let's say, right here, left click, and then right click. I could do... Yeah, let me uncheck these because these are variables, right? Now right click on the gray, Format Cells. And you could click Hide too, right? So click OK, and then come up here, Formulas, Data Review. I think I need to uncheck that. So go to Formulas Review, Protect Sheet, and click OK. Now, if I click on any of these cells, you don't see the formula up there in case you're trying to do some proprietary work. So that's a little bit of a tangent anyhow. So I like to protect them so that I can, when I finally get it to work, I just unlock these cells and everything else basically gets locked. But you know, this is kind of a work in progress, so it may change as we go, so I'm not too worried about it. What we've got is this, and this. So with this information, we can get the slope of G1, which is D2, the elevation of the point of vertical intersection divided by H2, which would be, in this, H2 is half the length, right? So you click on this, it's just A2 divided by 2. So there you get your slope of 1, and very similar, F2 minus Interesting. So, so there's R. C2 minus D2. So PVI minus protovertical tangent. Yeah, so then you're just getting the difference in height, difference in elevations of those two, the PVI and the PVT, divided by the same one here, A2 divided by 2. So instead, like that, it would be this, enter, right? And then R is E2, yeah, so G1 minus G2 divided by the length. So G1, F2, or sorry, G2 minus G1, yeah. So R is, if you look at this formula, you need R. And R is G2 minus G1 divided by 2, or divided by the length, right? And then here we're going to divide it by 2. So sometimes you'll see this formula, it'll be looking a little bit different. Instead of R, they'll have G1, G2 minus G1 divided by 2 times the length. So it might look like this. G2 minus G1 divided by 2L. And that would be in parentheses. And you might see that instead of that. It's just the way the algebra is explained. So one's using R. I actually kind of like this better, but I was taught to use the R, so we're using it here. So I should probably put in, that's R equals, get rid of this, right? And then, no, I think R is that divided by L. That's R, and then you'll come back and divide it by 2, the 2 that was here after. So anyways, there's just different way to get the, so you may not see a formula like this and go, what's going on? It's different, but it is, one's using R and one's just using G2 minus G1. All right, so there's R. F2 minus E2, which is G2 minus G1 divided by the length. Right? And then there's your PVI, A2 divided by 2, length divided by 2. So now what we do is we go in here and we say, okay, so this is number 0. So along our stations, there's station 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? All the way down to 29.3034. And I don't know how to put the plus state. I didn't put the plus station markings in there. That would be 29 plus 3034, right? And that would be 0 plus 0, 0, 1 plus 0, 0, 100. This is in hundreds of feet. And we have Y. So this is when we get into the formula. So I sort of bundled it all together. What I'll do is I'll take this area here, this formula. So I'm picking up the PVI. It's not needed for the formula. I don't think there's any dependence there. Oh yeah, so there is, I'm not sure why. Let's see. Formulas, remove arrows, okay. So we need PVI, elevation PVI is 683. So I've got, so in the formula, not sure why I've got that. G1, okay, let's just do this. G1, that's the grade of positive grade there, times X. And, oh yeah, okay, so what I'm doing is I'm trying to find the elevation of, what's the elevation at the PVI. So let's go back here, I'll show you what that is. The elevation of the, at PVI, what's the elevation right there? And here it's showing it as midpoint and 414.27. So we're trying to calculate what that is. there's the solution for 14.27. So what I've done was, this was the x, right? If I given x, you try to find out what's y. And let's see. So PVC, point of vertical curvature, I'm given, that's a given, that's 0, right? The station that we're starting at. And G1 times x. So if you go here, you look at G1, 46 times x. So we're going to say E2 times F10. So G2, E2 times F10. That's what the formula is there, and that'll give you the 683, which I think is just, I don't know, I'll tell you what it is, part of the formula. So let's look at 683, thinks that comes out to the vertical difference between these two. And that's kind of important that you, when you're doing this, see, G1 times X, people, well, it's just part of a formula, but that's good to know what that number is, right? And then R2, R divided by 2, is we just did the same thing. We're just going to go back and look at R, the rate. And I'm not going to try to explain what that is, but then we've got R here divided by 2. So that's all I did was take R and then divided by 2, right? I'm assuming I could zoom in there. And then x squared is just this squared, right? And that's the caret, gives you the square. So we're doing state. So this here was just given that in feet, because if you're going to use it in an instrument, you're going to need it in feet and or in coordinates. And then vertical. So then I just take this formula and put it all together. So that would be point of vertical curvature, right? PVC plus the G1, that's the elevation there, plus I10, which is this portion here, yeah, which is already divided by 2 and then multiplied by the length on the bottom, and then all that multiplied by the squared, x squared. So that's pretty straightforward, right? And let's see, so now we're going to go to over here, and it's going to be basically the same thing repeated. So then that just gives me an idea how to get the numbers together, so that when I put them over here, I can see the numbers, see that I can follow the same thing that what happened over here. So I would go B2 PVC, right? B2 right here, B2, and then plus, so then I'll put a plus there, and 683, so G1 times X, so that's what I did there. E2 is G1, and then X is A5, is referring to itself over here, the station. And then we get to plus, and then I did the same thing plus. And then I get R, which is, R divided by 2, which is G2, right? It's referring to the green cell here, divided by 2. The 2 is a constant, doesn't change. And then we get times A5, which is X squared, right? And then that's the formula for the Y on this station 0. So then we get the multiplier. I'm not sure. Oh yeah, so anyways, this is just in feet. So I'm looking for coordinates. So I'm taking this and multiplying it by 100. So station 1 is 100. Station 10 is 1,000, right? So that I can actually get coordinates. All right, and then you concatenate these, right? So C5, which is B5, B5. Oh yeah, so we were using the multiply for X, right? It's kind of going, X is over here. Let's go back over here. So there's your station X. Here's your coordinate feet in X. So I'm going to take this, which is C5. So I'm going to type equals C5, and then the and, I forget what it's called. I forget what the and symbol is called. And then open close quote over a comma, because you want to have a comma in between, and then B5, which is 0. So let's look at one here at station 2. We did the formula, so we have the y coordinate, and that's in feet. We have the x coordinate, and that's in feet. So we're going to concatenate those. So C7, which is x in 100 in feet, or 200 in feet. And then we're going to use that concatenate. It's actually not concatenate. It's just adding these things. So and if you're going to concatenate, you'd say equals concatenate open parentheses C7 comma, and then you would have the open quotation comma, close quotation comma, and then a comma, and then B7. That's how you concatenate it. Here we're just using the and symbol, and then that's how that works. So then you got your XY coordinates, and then Z. I didn't put Z's in here because it's not, it's a vertical curve alignment, and it's not part of the what I'm trying to explain. So then pretty much it. You come over here, you would want to check, make sure everything's adding up. Your end station is matching your end station, and that your vertical elevation on your last point matches, and then maybe look at, you could check anyways, that's how it goes. You want to check some things before you take them. And just go right click, copy, then you go to AutoCAD. So we could take all this information right here, delete it, right? So we have this point, this point, this point, and the lines connecting the two. That's everything we got. And let's make sure this is at 0, XY, 0, that's at 0, 0. Then I'm going to type in PL, enter. And then I'm going to just Control V, enter. Didn't work, did it? PL, enter, Control V. Oh, so it's in inches. So you could, AutoCAD's the weirdest thing. So actually, it's not scale, it's all scaled in inches. That's funny. So let's just go scale. There's a whole nother issue with AutoCAD. Everything's here is already in feet. So 165 feet be like, thousands of inches. So let's just scale that up. SC, enter. I should. And then just put it in that direction, right? In the positive right-hand direction, and type in 12, enter, and then there's your vertical curve alignment. So now let's look at the coordinates. Let's put this in, draw points. Let's see what the point style manager looks like. Format, point styles. That's good. And then we'll just do 25, enter. And then formulas, tool, draw points, multiple points. Do the same thing there, Control V, enter. Control V, enter, right? The points didn't populate, did they? Oh, there they go again. God dang it. There. So let's take that, scale it. Enter. Anyways, that's how you're, this is the unplanned part of the video. So now I got coordinates going along that thing, right? And then obviously you could add the point there and the point at the crest. I'll show you that in a second. And then here, so in AutoCAD, there's called a Lisp routine, something Mac, LeMac. Got a bunch of great Lisp routines. So I'm gonna upload. You'd have to type in upload, app load, right? Load, and loaded successfully, close. So now if I type in here app load, enter, it's going to come up, no, numinc. All right, I'm going to come up with this thing. So I'm going to start at 0, right? That's our station 1. Increment of 1, and then we could do a plus 0, 0. No, plus 0, 0. That's all our stations, right? I could add that. I'm not sure how to add that. And then uncheck text follows cursor. Sections to increment prefix, right? That's it. And then middle. No, we got, that's the name of the block that I created. There's a video on that, how to create a decimal foot block, which is funny because we're going around it here. Scale of 12, so it's going to be a foot tall. We could go 6, let's go 18, about 1.5 feet tall, and pretty much it. Now we just go, we don't need to do any of the rest. So here I'll just come in and hit there. Okay, so the scale, right? So the scale's not good, right? We need to do right here or something like that. So it needs to be like, let's do a dimension, I think. Right here we could do, because it's all in inches, right? What happened to my, so let's do this. That looks pretty good. Let's say we had make our text 12. It's interesting, so I think I gotta go 12 again, right? 12 feet, 12 inches, right? Delete. Let's do that again, numinc. And then go starting at 0. Scale would be 144. Let's go to 144. 180 plus 36, 220 or something like that. Let's try that. All right. And then we just go through and start hitting those points. You know, in this case, I would probably go to node set. I'd go to my snap settings. You don't want to miss one here. And then that way it just snaps on the, anyways, I'm showing you, I don't need to do them all, but the nice thing about this now is I can use that leader. So we could hit all of these and then start moving them around a little bit. Huh. So that's how you get it. And then you got to remember those are all updated as you put them in, but then regen, if in case something, let's say this moves to there and you realize there's some errors and you need to start changing, so you need to hit regen. See, look, it's at 900 comma regen, and it's at 1,000. So, but it doesn't update without you hitting regen. So let's say you had this leader and you just want to take it and copy it. You could go like this, copy. All right, this is what I want to copy. Oh, that's not what I want to do. Copy. What am I doing? Maybe because of the location I was hitting. I'm just going to paste it there. That's weird. I never did how about this? Control Z, Control C, Control V, And I never had that problem before. Let's do how you do that. Edit, copy with base point, and you have to select something first. Edit, copy with base point, and then you can just enter, and just start pasting it in there. Maybe not. I don't know what's happening, man. Edit, copy with base point. All right, and then go Control V. There you go. Control V, enter, 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 enter. But you're not going to get it if you didn't have the num ink. You'd have to come here and manually change those, right? You could double click on it and then you change the value to 10, enter, and then hit the next one. Okay, apply. Okay. See how we changed it to 10, and then you can change those manually. That's how you do it without that num ink. That's what I know about that. So, and then the rest of it here is finding the point of vertical intersection. Sometimes you don't have a formula, you can't remember the formula. The rest of it is pretty much just a compound parabola. I don't know what you want to call it. It's a symmetrical parabola. It's not even a compound. Yeah, it is. So this is a single parabola up to here, and then this is another parabola up to there. So if you know the parabola formula, you could find the high point and then just use the slope. You just use the parabola formula on either side. It'd be a different formula for either one. I'm not that keen on that. But so what we're going to do here is we have the elevation difference between PVC and PVI. So we're going to come down directly below this line, right? The length is still 2930. So right here, I'm going to go like this. I'm going to change the color of that to red, okay? And then let's change the thickness to 35, enter. Alright, so now we know this is the same length as the length. This is our length, right? And then that's our elevation between PVC and PVI, 683.22. And it's going up, it's in a vertical position, and then from this side, the vertical distance is 392.59, vertical down. So we're going to go down from that red line. And now we have the length, and we have the vertical up, and then the vertical down. Now we're going to connect that with the line that goes across here. So that's, let's do that. Change the thickness of that to like 35 also. And now we have a right triangle that goes from the lowest elevation to the highest elevation with the same length. So let's do this. H, and leave it right there. Let's do the same thing. MA, enter, click on that, and that. Yes, enter. So I'm going to leave that alone, but that's also kind of the big triangle. All right. So what do I do? So now we have a right triangle. So these triangles are similar. Both of these triangles here. So if we did the angle on those, you'll see they're the same dimension. What happened here? I don't want that, do I? So dim angle right there. This angle right there is 20 degrees. I don't know if it's 20 degrees. Let's take a look in the format dim style. This is, I was just working with AutoCAD, trying to refresh my stuff with AutoCAD. So that's what this is, the program. This is the project that I picked. And then decimal degrees, precision, let's go 4 decimal places. Okay. Set apply, set current, and then close. So now we have an angle there, and then let's do the same thing there. See, those are all the same angle, right? So they're all similar triangles. Now we got, so what I did, I just showed it. So it'd be so the overall, right, is 1075 is to the horizontal, right? Vertical is to horizontal, vertical of the green to horizontal of the green, gives us a ratio of 0.367. So then the ratio of these two is also the same. So we know that the distance between here and here, the vertical distance, so the 683.22 is to x, same as this is to the horizontal here, this vertical is to the x here. So there's the algebra there. 683.22 is to 0.367, and you get your 1860.985, 1860.1460. No, this should be 1860. Oh yeah, there you go. All right, 1860.985, and that's your PVI. That's the X for the PVI, right? And then if we go back to here to the Excel, you got PVI. Yeah, 1465. No. Oh, let's see. Yeah, there you go. 1860. It's just station, so it'd be 1860 feet, but it's 18.6. That's our station. 18 planes plus 6098, right? And then so what I did here is I just plugged that into the formula, this formula. That was the station, PVI, PVC, G1, or this, and then X squared. It's just referring to this X squared, so that's the only thing that really changes here is just the X. And then I did that, multiplied it by 100, and then this is our PV, that's the point of vertical intersection on the Y, right? So I just did the same, that there is the same formula as we had here, right? And then we have this, so then we could take, actually we could just do this too. We go equals, concatenate, I'll show you the concatenate. This cell, comma, open parenthesis, open quote, comma, close quote, comma, and then there, and then close parenthesis, enter. That'll give us that. And if we went here, copy, and then we went to the AutoCAD, and we could type in, and we had to scale it again. That's so funny. And then just draw a point, P point, and then paste that, Control V, enter. Then we have to highlight that, added an extra one there. Take this, scale it, SC, enter, hit the origin here, and go 12, enter. We should have a point right there at the PVI, or at the crest, right? So there's a little variation because that's a straight line. When I did the PO, I just did straight lines. And then there you go, you have an exact location of that. So let's do that. Let's do block, and actually enter. Pick the block, right? So you have to have that block has to be on in here already, and I'll just fill it in later. Okay. Different block or name. Yeah, oh yeah, insert, enter, block. And then I told you I'm just working. So now we have the option, okay, click OK. So then I would just say, if you double click that and then right click on the value and then edit the value, we call that the crest. Enter, and then there you go. Okay, there you go. That's how you, and then we scale that up. SC. All right, That's how you get that 1860, 98, 433, 89. And that's what I know about. And the nice thing about this whole thing was just so you don't have to remember the formula, G1 minus G2 divided by L, whatever that is. I forget what it is. And then if you did actually this 86, 83, if you did this in the percent, the vertical, which is going to be very small, and percent vertical, very small, over the 29, the L, then you would actually be able to use the area underneath that point. So that let's say this the PVI, the center, and you got the area, the triangle there, you would be able to use that area as the vertical rise. But it's a lot of work to do a lot of times to get information, but it'd be kind of useful if you forgot the formula there and you were on an exam. And it's very delicate too, so like you have to carry out the decimal places very far to get an accurate number. And that's what I know about vertical curve alignments. Whether that helps you, and maybe that helps you in your career. I hope so. And thanks for watching.